Here's your passage with proper punctuation and paragraph breaks to improve readability. Imagine looking on the horizon and witnessing a sunrise that occupies half the sky. NASA has released images of a never-before-seen phenomenon where a star named Betelgeuse blew its top off, ejecting a gigantic portion of its surface mass. The event is known as a surface mass ejection, and according to the Space Agency, the ejection was 400 billion times the mass of an ordinary solar flare. From our sun scientists describe the event as watching stellar evolution in real time, with a star blasting off such huge chunks of its physical form. Surprisingly, the catastrophic explosion of this super-red giant is upsetting much of what we know about the universe. Why did Betelgeuse blow off its top, and how will that affect the universe? Let's find out. The significance of Betelgeuse. Constellations are made up of many stars and are arranged in accordance with mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant ruby red, glittering star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. When viewed attentively, astronomers recognize it as a seething monster with a 400-day-long heartbeat of regular pulsations. Because of its dim orange-red color, Betelgeuse is easily identified. It's ideal for convincing doubters that stars do, in fact, have different colors. It is also known as Alpha Orionis and is the second brightest star in the constellation, after the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations due to its variable nature as well as its odd name. Frequently, stars with the name Alpha are the brightest stars in their constellations, even though Rigel, Orion's other bright star, is actually brighter. It is also one of the most well-known stars. Interestingly, Betelgeuse served as a model for both the character and the movie Beetlejuice. Betelgeuse's proximity and characteristics. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and is the 10th brightest star overall in the sky. Earth is relatively close to Betelgeuse. Astronomers are unable to pinpoint Betelgeuse's exact distance from Earth, although they estimate it to be between 430 and 724 light-years away. It is the brightest red supergiant star and the closest to Earth in our galaxy. Only about 200 red supergiant stars have been identified. The Sun has a radius that is around 764 times smaller than Betelgeuse. If Betelgeuse replaced our Sun in the solar system, it would extend past the asteroid belt and even beyond Jupiter. This suggests that Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 16,128 times as massive as the Sun. This supergiant has 26,000 solar luminosities and is visible from 548 light-years away. The star has a surface temperature of about 3,600 Kelvin, making it cooler than the Sun. Only about 13.3% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would overtake Sirius as the brightest star in the night sky. Mass ejection and surface changes. Betelgeuse loses about one solar mass every 10,000 years. The star is surrounded by a nebula because material is being ejected unevenly in all directions. A cloud of material 250 times larger than the star itself surrounds Betelgeuse. The size of this nebula is also thought to be 30 astronomical units, equivalent to the distance between the Sun and Neptune. Our Sun regularly ejects mass into space, known as solar flares. However, the Sun only exhales tiny fragments in its outer atmosphere, called corona, giving rise to a phenomenon known as coronal mass ejection, CME. As a result, coronal mass ejections and surface mass ejections can occur separately. When a star ejects part of its unstable outer atmosphere, it causes a CME known as the corona's CME. CMEs from our solar system occur very frequently and can impact Earth. They can travel more than 1,800 kilometers per second, ejecting magnetic fields and plasma into space, sometimes reaching Earth within hours. A CME can disrupt satellites, power grids, and even pose risks to astronauts in orbit. The mystery behind Betelgeuse's explosion. A recent discovery shed light on the exceptional surface mass ejection of Betelgeuse. In 2019, the material that the star ejected exploded into space, cooled, and produced a cloud of cosmic dust, dimming Betelgeuse's brightness from Earth-based observations. Betelgeuse's renowned steady pulsing pattern has also been altered. The CME on Betelgeuse is unusual because it released 400 billion times more mass than a typical CME, causing the star to tremble like a dish of gelatin, according to NASA. Is Betelgeuse going supernova? All red giants, including Betelgeuse, are perishing. Observing this process allows researchers to learn more about stellar evolution. When a star is born, it consists of hydrogen, which undergoes nuclear fusion under gravity, creating helium and releasing enormous energy. As the star ages, hydrogen depletes, leading to fusion of helium, carbon, neon, and iron. When iron fusion begins, the star collapses in on itself, leading to a supernova explosion, one of nature's most powerful forces. Betelgeuse is expected to explode within the next 100,000 years, according to NASA. However, cosmic time is vast, and red supergiants die relatively quickly in comparison. Will Earth be affected? No. The explosion of Betelgeuse won't destroy or even partially impact life on Earth because it's too far away. For a supernova to be dangerous to humans, it would need to be 50 light years away. Betelgeuse is over 10 times farther than that. Instead, everyone on Earth will witness an extraordinarily bright star in the night sky. Final thoughts. Betelgeuse is not only a key star in the Orion constellation, but also plays a vital role in the study of stellar evolution. Its massive size and unique characteristics make it an exceptional laboratory for understanding the life cycles of massive stars.